Okay, what you see in front of you is a probability question asked in a calculus test. Okay, asked in a calculus test. At least I was told that it was asked in a calculus test, and many of the people who gave this test have not taken any probability course. So let's approach it in a more calculus kind of way. All right. So what we are given is we are given a function f defined on an interval. Okay, defined on an interval. This interval is 0 to infinity, and another thing is that the function f is continuous on this interval. Okay, continuous on this interval. So in that case, in such a case, for f to be a probability density function, what we should have is that first we need to have fx is greater than or equal to 0 for all x greater than or equal to 0. Okay, for all x greater than or equal to 0, since the domain is x greater than or equal to 0. Next, integration of fx must be 1, and the limits of integration must be the limits of the interval. Okay, 0 to infinity, like this. So this is what we should have. Now let's see. Take any x greater than or equal to 0. Okay, take any x greater than or equal to 0. Then e to the power minus theta x is always positive. Now theta is given to be positive. So theta times a positive quantity is again positive. So for all x greater than or equal to 0, we have fx to be strictly greater than 0, which simply means it's greater than or equal to 0. Okay, this part is done. Now let's look at this integral. By definition, this integral is equal to limit k tends to infinity, integration of 0 to k, e to the power minus theta x. Now let's see. It's theta e to the power minus theta x. If you put theta here, then it's independent of x, so it will come out. And again, since it is independent of k, it will come out of this limit and it will stay somewhere over here. Okay. So by definition, we have this integral. Now, so this is theta times limit k tends to infinity. The integral is e to the power minus theta x over minus theta 0 to k. So this is theta times limit k tends to infinity, and what we have is e to the power minus theta k over minus theta minus, we have the minus from the formula, and this minus, so this will be 1 by theta, okay, plus 1 by theta. So because if you put 0 here, it will be, the numerator will be 1. Okay, this is it. So the limit doesn't apply here because it's independent of k, so we just need to use the limit to this part, and we know that since theta is greater than 0, we must have limit k tends to infinity, e to the power minus theta k to be 0. Okay, we must have this result. So using that result, what are we going to get is, we have this theta as it is, times this is 0, plus this is as it is. So this is theta times 1 by theta equals to 1. So we've shown this, So we've shown that fx is a probability density function. Okay, probability density function. And we also need to find the expectation of x. So for that, what should we do for that? We need to use the definition of expectation of x. Okay, expectation of x. Let's write it as ex like this. It is equal to integral with the limits of the interval, the probability density function, times x. This will be the definition of expectation of x. So this will be equal to, as before, limit k tends to infinity, 0 to k, x as it is. Now this theta will come out to this place, and since it is independent of k, it will come out all the way out. Okay, so this will be our expectation of x. So for that let's first evaluate this integral x e to the power minus theta x dx. This is equal to first function into integration of second function using integration by parts, okay, minus integration of derivative of first function times the integral of second function. So this is basically x e to the power minus theta x over minus theta plus 1 by theta times this is e to the power minus theta x by minus theta. So basically it simplifies to something like this, e to the power minus theta x over theta squared. All right, okay, quite good. So we need to apply the limits 0 to k. Okay, 0 to k means 0 to k x e to the power minus theta x dx will be equal to x e to the power minus theta x by minus theta from 0 to k minus e to the power minus theta x by theta squared 0 to k equals to, if we plug in k, we are going to get e to the power minus theta k over minus theta, and if we plug in 0, we're going to get 0, so let's leave it. Minus, if we plug in k, we're going to get e to the power minus theta k, over theta squared, minus, if you plug in 0, we're going to get 1 over theta squared. Okay, 1 over theta squared. Now, to find the expectation of x, we need to find the limit as k tends to infinity of this value. Okay, so limit k tends to infinity, integral of 0 to k x e to the power minus theta x dx is equal to limit k tends to infinity k e to the power minus theta k over minus theta. Okay, and if we use the limit to this part, we do not need to apply the limit here because it's independent of k. And if we apply the limit here, just like before, limit k tends to infinity, e to the power minus theta k will be 0. So this part will be 0 after applying the limit. So minus plus 1 by theta squared. That's what we are going to get. So this is 1 by theta squared plus limit k tends to infinity, k e to the power minus theta k over what we have, minus theta, or we can say 1 by theta squared minus 1 by theta limit k tends to infinity, k e to the power minus theta k. Now this limit will be 0. And how is that? Okay, let's see. Okay, we're going to see that. We're going to see that. We need to see that limit k tends to infinity, k e to the power minus theta k. Limit k tends to infinity times k is equal to infinity, and limit k tends to infinity, e to the power minus theta k is equal to 0. So this is 0 times infinity form, indeterminate form. Now if we write it as limit k tends to infinity, k over e to the power theta k. Okay, then since theta is greater than 0, limit k tends to infinity, e to the power theta k will be equal to infinity. Okay, we know that. That's a standard result. Now, what we need to do is, okay, we have this form. This is an infinity by infinity form. Infinity by infinity form. So, this is equal to, now let's differentiate it. Let's differentiate the numerator and the denominator with respect to k, okay? This is 1 over, this is theta times e to the power theta k. So this is 1 by theta, limit k tends to infinity, e to the power minus theta k. We already know that this is 0, so this is 1 by theta into 0 is equal to 0. So basically this integral reduces to 1 by theta squared. Okay? So this integral with the limit is equal to, we already have theta times, this is equal to 1 by theta squared. 1 by theta squared. So this is 1 by theta. Okay. Alright, that's it. That's it for today. And thanks for watching.